Hi, it's Mr. Kane here, and it's awfully good of you to join me for this video about the eye and colour. I'm not sure if this should be entitled an eyeful or a handful, but whatever the case, I've got my eye on you. So let's continue through and let's have a look at the eye in more detail. So here it is, a cutaway view of the human eye, and we need to know some key parts and what goes on and what goes where. What's happening. So what have we got? Okay, we'll start out the front with the cornea. Let's try to underline that. The cornea is this bit around the front of the eye, on the outside. If you poke your finger in the eye, you touch yourself on the cornea. If you wear contact lenses, that's where they sit out here, on the front here, to help correct your vision. And if you're wearing glasses, glasses are held out here. Okay, right, get rid of that. So that's the cornea, the very front of your eye. What's in behind there? In behind there we're going to have the pupil, and then when you look in the mirror and you look at your eye, you'll see that there's like a black hole in the middle. That is your pupil. That's where the light goes through into your eye, and the size of the pupil is controlled by what's called the iris. That's the coloured part of your eye. So here's the iris there. It's a ring right around the eye. It's the coloured part, and it's like a muscle that controls itself to close itself into the middle here. Oh, it's getting a bit confusing here. So we'll do that again. So it can go in and make the pupil smaller, or it can go the other way and make the pupil larger, depending on how much light we want to get into our eye, whether it's daytime or nighttime. Behind the iris we have the lens. This is the lens here. Right, the lens. And it's controlled by muscles on either side, actually all the way around it really, because this is a cutaway view, and those muscles change the shape of the lens. They can pull it thinner or it can be fatter, and it all depends on what we're looking at. Things close away or far away, sorry, that doesn't make sense, far away or close in, and it changes its shape to make things focus on the back of the eye. On the back of the eye we're going to have the retina, and that's like the screen, the covering on the back of the eye, goes all the way around the eye, and that is where the nerve endings that detect the light are found, and they detect the image and send it to the brain down, where is it? Down the optic nerve, this thing here. So the optic nerve takes the images detected by the retina and send it to the brain, and we can steer our eyes in different directions by the muscles that attach the eyes, top and bottom and side, so we can steer it backwards and forwards and round about. So that's the eye. In reality it is quite similar to a camera. So a camera has a case. So a case in the camera, we have the sclera, or the outside of the eyeball, and just as in the camera, this keeps the light out of the camera, the sclera keeps the light out of our eye. And the inside of the eye has got this black coating to stop light reflecting around all inside it, called the choroid. Inside of a camera case is all black as well. Although we don't go poking around inside cameras much these days. This is like an old school camera, and this one here, which actually has a roll of film in the back of it. Modern day cameras have a CCD, a charge coupled device that detects the light. But when you're opening the back of an old school camera, you'll see it's all black on the inside to stop light reflecting around, so we only get light to go where it needed. The back of the eye that detects the light, that makes the image, is the retina. And this camera, the old school, it's the film, or a new cameras will have a CCD in the digital camera, and that's what records the image in those. We have an iris from the eye to control how much light goes in, and in a camera there's an iris diaphragm here that we can change to how much light goes in. If you've got one of your fancy cameras, this is what you adjust your f-stop with, how much light's going to go in. Out front of the eye we've got the lens of the eye. Cameras have a lens too. Our lens is quite, we can modify the shape of it, things that are close up or far away. In the camera it'll move backwards and forwards to help it focus, and with some cameras, this one you can see it's got an interchangeable device here. We can take out this lens, oops, go away, and we can change the lens and put a different lens in for different views of different things. And out front of our eye we've got the eyelid, which is a bit like the shutter that opens and closes when we create images, but this also keeps our eyes clean and free of dust. And cameras have a shutter in the back, and we put a lens cap on to keep things clean there. So it's quite similar to a camera. I mean, it has many parallels to a camera in the eye. But what do we use it for? We use it for seeing stuff and for detecting colour and so on. So let's look at some colour factors. So what exactly is colour? So light, or white light or sunlight, is made up of 7 colours of the rainbow. Okay, so yes, your Roy G. Biv: red, orange, yellow, green, blue, indigo and violet. That's where your colours come from, the different sort of parts of our rainbow, the different wavelengths of light. And we see that in a prism. When it gets split up, the white light or the sunlight that contains all the colours comes in, it gets refracted here, changes its direction, and then it gets refracted again and comes out. Because each wavelength gets refracted a slightly different amount, it spreads out until we get the rainbow appearing. There's different wavelengths are spread out. And we can mix them back together. We can separate them and we can mix them back together. We've got the 3 primary colours, the red, green and blue. We put those together and we get white if we put them all together. And these are the lights that are used in plays and shows at the theatre, and also in your TV screen to make the colours there. We've got the secondary colours, we call them cyan, magenta and yellow. We put those together, we get black. So the first 3, red, green, blue, we call additive. The second 3, cyan, magenta and yellow, we call subtractive. And those secondary colours, that's what's used in printers to get all different colours in the printer. Okay, so here's a picture of those being put together. You can see that the additive colours, we've actually get cyan, yellow and magenta here already. We put those together from green and blue and so on. And in your subtractive colours, you can get the green, the red and the blue there also. So we can mix colours in many different ways, okay, any colour we want in printers or in TV screens. How do we actually see it though? How do we detect it? Okay, we're seeing colours because what is reflected back to our eye. So yellow, for example. The yellow light's reflected back to our eyes. All the other colours are being absorbed, so we only see the yellow. Every colour is shining on it, but only the yellow is being reflected back to us. So, how are rainbows formed? Well, rainbows, we've got sunlight coming in, going into the raindrop, which bends the light, and then the back of the raindrop's like a curved mirror and reflects the rain. So, hopefully we can zoom in on this a bit closer and you'll see what I mean. So it's being refracted first and then reflected out the back. So look, sunlight's coming in, it's being refracted, and then the back of the raindrop's like a curved mirror which reflects the colours back out to us. And depending where we're standing, what colours we see where. It makes the curve of the rainbow. And here we go, here's a beautiful rainbow. And if you look closely at it, you can see multiple layers beneath it, okay, but there's really the clear rainbow here. And if you look at the secondary one, you'll see the colours from the primary one are reversed. So here's the reddy one and here's the reddy one here. The colours in the secondary one are reversed. Right. When we shine coloured lights on things, some strange things happen. So in this picture here, we've got normal white light being shone in, and we can see it being reflected back off the playing card. Only the red light's being reflected back off the red symbols here, so it gives us the red colour. We've got a mixture of colours giving us the purple of the grapes and this particular green of the capsicum there. So when we shine red light on it, we only get red reflected back to us. Okay, so it looks red. the markings have disappeared because everything is red. The grapes, they're made a purple colour, so it's made of a bit of red is in there. The same with the dark green, a bit of red is in that as well. So that's why we see it a bit. When we get to shine green light on it, there must be some green in the colour of the grape, so we get a bit of green coming back. Definitely green in the capsicum. In the playing card, you're only able to reflect green light back to us, so this looks all green. And there's no red to reflect back to us, so the markings actually look black. Similar thing happens over here with blue light. There's a blue in the purple colour, quite a lot of blue, so that's why we see lots of blue coming back to us. We see quite a bit of blue off that particular green shade of capsicum. The card is only reflecting blue light, and the same thing. There's no red light to reflect, so these parts look black. So it all depends what colours come back to you. So white light, red light, green light and blue light, what comes back. So to sort of recap, wavelength is the secret to our rainbow. Okay, so we get the rainbow. Light's got different wavelengths, which means different colours or energy. And there we go, there's the Roy G. Biv appearing there. And you might have heard of ultraviolet or infrared light. So our eyes can't always detect the light if the wavelength's very long or very short, so beyond the red or infrared and beyond the violet or ultraviolet, because we only see what's reflected back to our eyes. Okay, so it's all about eyes and colour. I hope that's been helpful, and if you have any more questions, just catch up with your teacher, or you can rewind the video and hopefully see what you missed the first time. Okay, thanks very much.